So I want to explain graphing a quadratic that has an a value that's a fraction, right? We've done this before, but this is a special one. You'll see why in a bit. So whenever I ask you to graph by plotting some points, you're obviously going to start by finding your most important point, which is a vertex. And to find that vertex, which is actually a location, x, y value, it's a coordinate. To find that vertex, you can use a vertex formula, x equals negative b over 2 times a. And when you use that, please replace the b and the a with parentheses. That way, when you identify the b value of 4 and the a value of 1/3, it's easy to plug in the b value of 4 and the a value of 1/3, okay? The c value is 2, but there is no c in the formula, so that's it, right? X equals negative b over 2 times a. X equals negative 4 over 2 times the a value is 1/3. Now, when you work this out, you're going to end up with a negative 4 divided by 2 over 1 times 1 over 3. That's 2/3, right? You could do that on a calculator too. Just go 2 parentheses 1/3, hit equal, and it'll give you the fraction 2/3. And then when you do negative 4 divided by 2/3, if you write it horizontally instead of vertically, it'll read this: negative 4, but with the division sign instead of the division bar, divided by 2/3. And remember that when you're dividing by a fraction, you really change the division to multiplication, but you have to flip the second fraction. So when you're dividing by a fraction, you're really multiplying by the reciprocal. So negative 4 divided by 2/3 really becomes negative 4 times the reciprocal of 2/3, which is 3/2. Or once again, you could simply type it into your calculator, negative 4 divided by 2/3, and it'll give you negative 6. Because right here, when you multiply the negative 4 times 3/2, it's like saying 4 divided by 2. 4 divided by 2 is 2. So you really have a negative 2 times 3, which is a negative 6. Anyway, your x value is negative 6. The x is negative 6. Now you still need the y. You simply plug in that x value of negative 6 into the x's, and then you do the math and you'll find the y. So I would rewrite this thing with parentheses. So it reads y equals 1/3 x squared plus 4x plus 2, right? But instead of x's, I put parentheses. Instead of x, I put parentheses. Now we could safely plug in that x value of negative 6 right in there. And then when you do the math, you could type it all into the calculator, and the calculator will do the work for you. It'll tell you your answer, the y value of the vertex. Or you could use PEMDAS, begin with negative 6 squared, that's positive 36. But you still need to multiply it by 1/3. So you're still going to multiply it by 1/3. And you could do that with the calculator. That will be 12. Or you could think of it as 36 divided by 3, which is 12. And then 4 times negative 6 is negative 24. Again, 4 times negative 6 is negative 24. Then the plus 2 comes down. So what you really have is 12 minus 24. That is negative 12. And then negative 12 plus 2 is negative 10. So we just found the y value of our vertex. Y equals negative 10. So that's going to go, I'm sorry, going too far. That's going to go right there, negative 10. So your vertex is negative 6, negative 10. That's the hardest part so far. And that's the most important point. So when you plot negative 6, negative 10, that will be the vertex down here, negative 6 on the x, negative 10 on the y. That would be right there, okay? Now, from that point, we need more points, so we're going to use the pattern 1, 1, 2, 4, 3, 9. However, we need to modify the pattern of 1, 1, 2, 4, 3, 9. Why? Because the a value is not 1, it's actually 1/3. So you're going to have to multiply the outputs of the pattern by 1/3. Multiply by 1/3. Multiply by 1/3. So your new modified pattern is no longer 1 over 1 up. It's 1 over and 1/3 of the way up. Okay, it's no longer 2 over 4 up. It's 2 over and 4/3 of the way up. And it's no longer 3 over 9 up. It's now 3 over, and 9 times 1/3 is 3. Okay, So from this vertex, you're supposed to go 1 over 1/3 of the way up. 1 over and only 1/3 of the way up. That's not even halfway. But on quizzes, it won't let you do fractions right here. It only goes to nice coordinates, not halfway or 1/3 of the way. So what you're going to have to do is go to a nice part of the pattern, and that would be the last one, 3 over 3 up, okay? So that 3 over 3 up, 1, 2, 3, 1, 2, 3, you put a dot right there. And of course, you map it over to the other side of the axis of symmetry, which is 1, 2, 3 units away, 1, 2, 3 units away. And there's your parabola so far. Now, if it were on paper, you would have actually done 1 over and only 1/3 of the way up. And then you could have gone 2 over and 1.25 of the way up. And you could have graphed those coordinates, mapped them over to the other side, and there's your parabola. But right here it says plot 4 points. We have 3 so far. We need 1 more. And we've already exhausted the pattern. So how could I get another coordinate here? Anybody? It's the easiest coordinate to find on a standard form quadratic. The y-intercept. How do you find the y-intercept? You find the y-intercept by setting x equal to 0 and solving. And on a quadratic trinomial that's in standard form, when you set your x's equal to 0, everything becomes 0 except your c value. So your c value goes right here. So that would be 0, 2. That would be the location 0, 2. And that right there is your answer to this question. And you can't even map it over, because if you go 1, 2, 3, 4, 5, 6, and you go 6 this way, it'll be off the graph. Excuse me. That's why it says plot 4 points. We have 1, 2, 3, 4 points. Hit submit. That'll be your answer. So let's plot 4 points of this graph. Again, we're going to begin with the most important point, the vertex, which is a location on the xy plane. It's an x value and a y value. It is a coordinate. How do you find that coordinate? You start with the formula, x equals negative b over 2 times a. And whenever you use this formula, please replace the b and the a with parentheses. I say this every time, and I see students not do this. You need to do this. That way it'll help you. It'll prevent you from making mistakes. When you identify the b, that's 3, that goes right in there. The a is negative 1/4. That'll go right in there, negative 1 over 4. So let's do the math here. We end up with a negative 3 up on top over on the bottom. If you do this on a calculator, it'll give you a negative 2 over 4, which reduces down to negative 1/2 on the calculator. So negative 1/2. Now, when you say negative 3 divided by negative 1/2, that's really negative 3 times the reciprocal of negative 1/2, which is negative 2. Okay, so negative 3 times negative 2 is positive 6. Okay. If you didn't see that or understand that, you could write it horizontally. Negative 3, bless you, divided by negative 1/2. You rewrite that as negative 3 times the reciprocal of negative 1/2, which is negative 2 over 1. So that's really just negative 3 times negative 2, which is a positive 6. I hope we all understand how we got a positive 6 as the x value of the vertex. This does say x equals, there it is, x equals positive 6. You need the y. All you have to do is plug in the x value of 6 into the x's of your original quadratic function. So when you write the quadratic function, replace your x's with parentheses. So y equals negative 1/4 x squared plus 3x minus 4. And we're plugging in that x value of 6 right in there. So I would begin with the exponent. 6 squared is 36. And you still need to multiply it by negative 1/4. So go ahead and multiply that by negative 1/4. You could do the calculator, negative 1/4 times 36. That will be negative 9. Okay, so negative 9 is this answer. And then plus 3 times 6 is 18. So that'll be a plus 18, because 3 times 6 is 18. And then the minus 4 comes down. So what we really have is y equals, that's a positive 8, negative 9, and positive 18. No, that's positive 9. Negative 9, positive 18 is positive 9. 9 minus 4 is 5. So the y value is 5. The y value of the vertex is 5. So 6, 5 is the most important point. So let's get a point and plot 6, 5 and put a dot right there and leave it there. That's the most important point. I know that this thing's opening down. I need more points. So I could go to an input-output table, or I could plug in, or I could do the pattern and modify the pattern. So the pattern is really 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. However, I need to modify the outputs, the 1, the 4, and the 9. I need to modify those outputs by that new a value of negative 1/4. Okay, so you're going to have to multiply everything by this new a value of negative 1/4. I'm talking about the outputs only, the 1, the 4, and the 9. So multiply by negative 1/4, multiply by negative 1/4, and multiply by negative 1/4. Okay, now your new outputs, that's going to be negative 1/4. This is going to be negative 1, and this is going to be negative 9/4. Now, the only thing I really care about, especially because I'm graphing on quizzes, are the nice ones, right? You can't go 1 over 1/4 of the way down. I mean, on a piece of paper, you would 1 over and only 1/4 of the way down. That'd be right there. But on quizzes, it'll only go complete units. So only do the nice part of the pattern, the 2 over, 1 down. So go ahead and go 2 over, 1, 2, and 1 down and put a dot right there. And you could map that over to the other side, 1, 2, 1, 2 of the axis of symmetry. Okay, because there's an axis of symmetry vertical line that goes right through that vertex. Anyway, we still need more points. And obviously, there's no other nice points on this pattern. So how else could I find a nice coordinate on any quadratic formula? On any quadratic equation. What's an easy point to find right there? Anybody? The y-intercept, okay? How do you find the y-intercept? Well, you set x equal to 0 and solve. And when you set your x's of a standard form quadratic trinomial equation, when you set your x's equal to 0, what do you end up with your c value of negative 4? So the y-intercept is 0, comma, negative 4. So I know it's going to cross at 0, negative 4 right there. And that would be the last point that you need to plot right there. So that's it. You put this point, that point, that point, that one. Obviously, if you were graphing on paper, you would show it. But if you try to reflect this over, it's 1 unit, 2 unit, 3 units, 4 units, 5, 6. When you go 6, you'll be off the 10 by 10 graph. So that's why I only ask you to plot 4 points, not 5 or not 7, because it would be off the graph. Anyway, I hope this helps.